Hi, fourth grade. We're going to be reviewing Chapter 21 together today. After this review, you'll take a short quiz on the chapter to submit your final understanding. During this review, all you need to have out is your notebook. I'll lead you through the rest. Go ahead and take out your math book and label it with Chapter 21 Review. You don't need to write down this vocabulary. We're just going to review it together. So you can rest your pencil after you get your journal labeled. One term that we started off with the chapter was congruent figures. Just as a reminder, that means the same size and shape. We don't have any practice problems for that here on the review, but there is one question on the test that asks which figures are congruent. So just remember that congruent figures means the same size and shape. So for example, I can have two squares, and although they're the same shape, these two are not the same size. Those are not congruent. I need them to be the same size and the same shape. These two squares would be congruent because they're the same size and shape. Then we talked about symmetry. We talked about two different kinds of symmetry. Line symmetry, which is when a figure is folded in half on a line and the halves match perfectly. Now remember, this does not involve any rotation. So if it's folded but then a part would have to be turned, that's not line symmetry. Line symmetry is when a figure can be folded in half and the halves line up perfectly without anything needing to be moved around. These can be vertical lines, horizontal lines, or diagonal lines. Next vocabulary word that we talked about was rotational symmetry. Rotational symmetry is when a figure is turned around its center and it can look the same in at least two places. For example, let me pick up one of these squares here, or both of the squares. As I turn the squares, they can look the same when I turn them in 90-degree increments. Squares have a rotational symmetry. So do circles. Lots of other shapes have rotational symmetry. For those, that means that they have to be turned around their center. We also talked about turns. Just as a reminder for you, a quarter turn is 90 degrees. A half turn is 180 degrees. 3/4 turn is 270 degrees, and a full turn is 360 degrees. When we talk about turns, we want to imagine a circle and dividing that circle into quarters. The first quarter would be a quarter turn, that's 90 degrees. Then an additional turn would be another 90 degrees, so that would be a total of 180 degrees. That would be a half turn. Then another turn would be 270 degrees. That's an additional 90 onto that. And then all the way back to the top is where we would have a 360-degree turn when it goes all the way back and arrives back at its original position. We also talked about clockwise or counterclockwise. The model I just drew is clockwise because that's the way a clock hand moves. Counterclockwise would be opposite, going around the back side of a clock. All right, so now that we've reviewed that vocabulary, let's do some practice together. So you can pick up your pencil again, and let's do some practice together. This is coming from your textbook, but you can just look on the screen today. I'll lead you through the whole activity. So first, we're going to tell whether the figure appears to have line symmetry, rotational symmetry, both or neither. So for this, I'm going to draw out the figure. I'd like you to copy it as well. The first one is just a rectangle. And let's talk about line symmetry first. So remember, that's when it's folded in half and the halves match perfectly. So a rectangle actually has a couple lines of symmetry. It has a vertical line. If we fold that in half, they'll match perfectly. I could also do it horizontally, and again, it would match perfectly as well. I can't do it diagonally on a rectangle because the pieces would not match up. It's like trying to fold a regular 8.5 by 11 sheet of white paper diagonally. It doesn't match up. Only squares can be folded diagonally as well. But this does have line symmetry. I'm going to just write line sim for short. Let's talk about rotational symmetry next. So if I take this rectangle, I'll draw out one and actually rotate it for you. If I take this rectangle and I turn it around, I need to see if it will look the same as a normal rectangle. So let's try a quarter turn. Nope. A quarter turn, it looks longer than it was before. If I rotate it around 180 degrees or a half turn, it looks back to normal. So yes, this does have rotational symmetry. So I can write rotational symmetry as well. All right, let's take a look at number 2. So we have this figure here. It looks like a do not cross sign. Let's talk about whether it has line symmetry. So if I were to split this straight up and down as it is, it would not look like it is symmetrical. If I split it like this, the center line doesn't line up perfectly. But what if I were to move that line of symmetry onto another side of the figure? What if I come at it at a diagonal? Do you see now that I've come at it at a diagonal, that center piece will line up with the other side? So even though I had to move my line diagonally, it still has line symmetry. So it does have line. Let's check and see if it has rotational symmetry. I'm going to take this and actually turn it for you so you can visualize it. So I'm turning it a quarter turn. It does not look the same as the original picture. Let's try a 180 degree turn. It does. That diagonal in the middle is the same as the diagonal on the original. So yes, this does have rotational symmetry, so we can write both. So like I mentioned, sometimes it's helpful to physically draw out the object and rotate and move it around so you can see for yourself. So on your test, you might want to have a scrap piece of paper nearby so you can draw out the figure and move the paper around a quarter turn at a time. All right, number 3, we have this figure here. It looks like a square with arrows coming off of it. I'm going to draw a quick sketch of that. All right, so looking at my very rough sketch, I can see that definitely I could split this straight down the middle. It would look the same. The arrows would match up when it was folded together. I could do it across the middle this way as well, and that would match up also. So it does have line symmetry. Let's take a look and see if there is rotational symmetry. I'm going to have to imagine that arrow was there. It didn't really attach, so that's okay. All right, so just imagine the arrow is there. I'm rotating this 90 degrees. Does it look the same? I'll rotate that as well and put it back on there. It does. It looks the same as the figure. So this one actually will have rotational symmetry whether I do it a quarter turn, a half turn, 3/4 turn. So this one has both as well. Okay, and then let's take a look at number 4. I am going to attempt to draw that out. It is kind of randomly zigzagged, so you can do that in your sketch as well. It doesn't need to be quite exact. We'll get the general idea. Okay, so looking at this, I notice that each side is different. So even if I were to split it in half or split the original in half, those lines are not going to match up. So because it doesn't have line symmetry, it also is not going to have rotational symmetry either. So it has neither for this one. All right. Now we're going to practice drawing some lines of symmetry. So let's sketch out these figures. Number 5 is a square. So like I mentioned, line symmetry needs to be, the sides need to match up perfectly when you split it in half, whether it's vertical, horizontal, or diagonal. So let's take a look at the square. We already know we can definitely split that vertically, and we've also talked about splitting it horizontally. Squares are unique because we can also split them diagonally. We can't do that with rectangles. They wouldn't match up. So we can also do that diagonally the other way. So squares have 4 different lines of symmetry. All right, number 6, we have a pentagon. Go ahead and draw that out the best you can. And pentagon, we can split it vertically in half. Those lines would match up perfectly. We cannot split it in half across this way because the top would be pointed and the bottom would be flat. So that would not line up. But if we turned the pentagon another way, we could match it up with another side as well. Actually, let me draw that in a different color so you can see that a little more clearly. So what I did is I just did it from the other corner, treating that right corner actually as like the top point. And then you can see that it would fold up perfectly as well. I could do that from all corners straight down to the middle, and that would line up perfectly as well. I'll change colors here so you can see. So if we come at it from the tip to the flat line, then it should all line up nicely. But I just can't split it from a diagonal side to a diagonal side. So that pentagon had lots of lines of symmetry. It had, let's count, 1, 2, 3, 4, 5. 5 lines of symmetry, 1 for each tip of that pentagon. All right, number 7. We have this wonderful large arrow. All right, there is only one way for this line of symmetry, and it is straight through the point down to the bottom. We can't split it in half any other way. It would not match up. Then number 8, it looks like 2 tips of triangles put together. There are 2 ways that we could do this one. We could do it straight down the middle, and then it just looks like separated triangles that could fold right over on each other. We could also do it across this way, and the triangles would fold in on themselves as well. All right, you guys are doing a great job. This will be our last set of questions before your quiz. I'm working on now thinking about lines of symmetry and also turns. So number 9 asks, which figure appears to have 6 lines of symmetry? So let's look at all of those from A through F. One thing that I know for sure is that like from the pentagon problem, the pentagon had 5 lines of symmetry because I could come at it from all 5 points. So I'm going to start off by looking at B, because I noticed that B is a hexagon and I know that's 6 sides, so I'm wondering if it's the same as a pentagon. So let's take B, let's draw out a hexagon. Wow, that's a really bad hexagon, but I'm going to do my best. Okay, so looking at B, I know that I can come at this. I have to draw a better one. I'm so sorry. That was awful. I can't even begin to do that yet. This one isn't as bad, but it's still not fantastic. Okay. So looking at this, if I split it across, like that, I end up with 2 trapezoids. So I'm going to use a different color for each one. So that was one line of symmetry. Let's see if I can do it through 2 other corners. Again, I end up with 2 trapezoids, so that works as well. Let's do it through another set of corners. Yep, I end up with 2 trapezoids. Okay, so I've done all of the corners. So now let's see what's next. Okay, let's split it through that side. Does that match up? It does. Okay, so that's 1, 2, 3, 4 lines of symmetry so far. So then I can also split it. Because I was able to split it across like that, I'll be able to do that on all the other lines as well. So let's see how many more that will give us. I'm going to split it across this way next. I end up with the same on each side. And then one more possibility would be across this way. And I end up with that as well. So I use 6 colors. That means 6 lines of symmetry. So the best answer for which has 6 lines of symmetry would be B. That 6-sided figure, we can split it at each line and at each corner, and we end up with lines of symmetry. All right, number 10. Which figure does not appear to have symmetry when turned 180 degrees? So remember, 180-degree turn is like flipping it upside down. So 180-degree turn is turning it across half of a circle or flipping it upside down. So I can tell right off the bat this letter V. I'll draw it out for you and I'll flip it. So this would be a quarter turn. This would be a half turn or 180 degrees. That is an upside down V. So this does not match the original picture. So E is not correct. Let's take a look. I am believing that L is not going to be able to be flipped like that either. So here's a quarter turn, 90 degrees, half turn, 180 degrees. Again, that letter L is upside down. All of the other ones would be able to do that, like the letter X. Let me draw that out for you and I will turn it. That would be a quarter turn, still looks the same. 180-degree turn also still looks the same. So X is able to be turned. So it's not that one. So we're just left with letter E and letter F, which was the V and the L shapes. Those cannot be turned 180 degrees and still be symmetrical. All right, number 11 says which figures appear to have symmetry when turned 90 degrees. So that would be a quarter turn. So let's draw those out. So we already know that the letter V shape and L shape are not possibilities. We already saw that. We did see that X was a possibility, so that's letter D, so we know that for sure. So we've already done that one. Let's take a look at the square. I'll draw a square out for you, and let's turn it. So 90 degrees, flip, and it's still a beautiful square. Okay, so that one is fine. That was for letter C. And then we have for letter A a circle. That is definitely going to remain the same. So A is fine as well. And then the last one we had was a hexagon. Let's draw that out the best we can. And I'll turn that guy around. 90-degree turn. Now, mine does not look the same because I drew my lines a little bit funky. But if I look at this one, I can tell all of the lines are equal length. And if I turn the original one, that will work. Mine did not because I didn't draw an equal length sides. But in the original one, it is fine. All right, we're going to skip number 12 and 13, and we're going to get you guys going on your quiz. So, the next part that you need to do is to go onto the Google form and take the quiz. Most of the questions are about lines of symmetry and turns. There is one question on patterns, which is what this next section was. I'm not going to go over this with you right here and right now. But what you do need to know is there is one question about patterns, but it involves doing flips. So before you take that quiz, make sure that you're comfortable with what we talked about, the quarter turns, half turns, 3/4 turns, and the degree measurements. And if you don't have that written down, I would definitely come back through and write down this example that I drew with the circle and the turns. That would be the most helpful to you. So we are going to have Zoom this morning at 11 a.m. So if you have questions, please make sure you come ready to ask away. And I would maybe hold off on taking your test until after you get your questions answered, okay? So I'll see you soon. Great work in this chapter. I'm so proud of you all.